Hello and welcome to this slide. Here we are going to solve question number 2 of the course of Engineering Economics. The question is from December 2018 exam of PENG in Canada. According to the question, RCC is a tier 1 automotive supplier. They are choosing between two 3D printing machines, A and B, of comparable specification to help reduce the time needed in building prototype for new parts and sub-assemblies. The company has a minimum acceptable rate of return of 8%. Expected salvage value for each of the two 3D printing machines at the end of their service life is 7,500. Answer the following question using the information in the table below. So according to the table, we can see that they have different service life, 10 years and 12 years. Down payment is different, running cost is different, and the maintenance cost is different, service cost is different. So now let's see and solve the question. According to this part A, state the necessary assumption for comparing mutually exclusive alternative of different lives. So as I told you, when we have different time period, what is the necessary assumption if we want to compare them together? So if we want to compare them, we have different methods. We have LCM and study period method. But LCM, least common multiple, is the one which we're going to use. We assume the alternatives are compared over a common time horizon. So LCM between 10 and 12 would be 60. If we want to compare them, exclusive alternatives, so we have to use LCM. In part B, based on annual worth comparison, which alternative should be selected? Comparing these two, which one should be selected based on annual worth? So we have to calculate the annual value. Annual worth for total for each of them is annual worth for each of them plus the present worth, which we change it to the annual worth, and the forward worth, which we change it to annual worth. For the maintenance, as it's mentioned here, according to the question, it's mentioned that the first price in the beginning, the price is 150 for the first year. After that, increasing but $110 per year. It's not about the percent. It's talking about the value. So in these types of question, we'll consider the first year as a fixed time, as a fixed value, and the second part as something which is gradually is going to be increased, and we'll use that compound table. Have a look. So for the maintenance, as it's a gradient annual worth, so we have the fixed one plus the other one, which is going to be increased annually, and we will add the number 1 for that one. So A of t is equal to A plus A of gradually increasing. A of t, for example, for the first one is 150, the fixed value. Each year we have this one. After that, we're going to increase 110 after that. So, and how do we impose the time? It's talking about the 10 years because the life is 10 years. So 10 minus 1 divided by 2. This is the way how we are calculating. So 150 plus 110 times 10 minus 1 divided by 2. The total value would be 645. So the annual worth of total is 645, which calculated here, 3,000 and 1,000, which is annual cost of the project for A, and 11,000 minus 17,000 times, as you can see, the total cost would be $5766.5. And for project number 2, we are doing the same, 900 plus 2,800 plus this is the fixed value, this is the value which is going to be increased. The time is 12 years, 12 minus 1 divided by 2. So this is the one which you have to know that for gradually increase, it's better to impose it like that. Plus 12,000 times, this is the one which we are founding from the compound table, minus 75,000 is the salvage value time annual over future for this timing. So the total result would be 5607. As you can see, this is less than the other one. So we have to choose project number B. In part C, it's asking you, based on present worth comparison, which alternative should be selected? Based on present worth comparison, which alternative? Based on present, because before we were using the annual cost, now we are using the present worth. And let's see that which one we have to choose. As you know, for calculating the present worth, we have to change the annual worth to present, salvage worth. This is the annual worth. We have to change the annual worth to present, salvage worth to present, and present worth, we shouldn't change it. So present worth of the running service, this is the annual worth. We have, according to this question, according to this question, we have 3,000. We have to pay 3,000. We have to pay 1,000 every year. So 1,000 plus 3,000. This is something which is annually should be paid. So if, as we want to have it on the present value, we will calculate present over annual. How many is the total life of this project is 10 years. And what is the interest rate? 8%. So the total value would be, that we will find it from the compound table. The total value would be 26840.4. This is the present worth for the annual cost. Now we have to calculate the present worth for the maintenance cost, for the maintenance. So we are paying $150 every year. So this is something annually. We'll consider it something as something annually. 150 times present over annual, 8% and 10 plus. This is something which is gradually increase. So it will start from the second year. In the first year, this is 150. After that is 110, which is increased every year. So gradually is 110 times present over gradually. 8%, how many of the life? I'm telling you that the first year we are not considering it in the first year. We are considering it from the second year. So it would be 8% and 9. So we'll find it from the compound table. From the compound table, the value would be 6.7107. Sorry, this is for the first part. The compounding from the compound table, the value of these parentheses would be 25.8081 times the gradually increment, which is 110. And this is the fixed amount, 150 times present over annual. These are simple things. You can find it from if you check the previous video, I told you that how you have to find this value from the compounded table, and I explained the question as much as I could. So this is the way which you can calculate the present worth of the maintenance. Now is the time to calculate the present worth of the salvage. As you know, it's mentioned that the value would be 7,500. As salvage something for future, we need some, and we are calculating the present worth, so we have to change the future to present. So we will find present over future. As you can see, this future can be omitted, and the last value would be present. It is 8% interest. The life is 10 years. So according to the compound table, this value is 0.4632 times 7,500. The total value would be 3474. Now is the time to add them all together. When we're adding them all together, this is from the first part, second part, third part, and if this 11,000 is the initial down payment, which is for the present. So we add them all together. The only one which is minus is salvage. The rest of them is the cost, but the salvage is the income. So the total value for if I want to calculate the present worth, the total value would be $37,771. Now I have to do the same for project number B. The running and services, it would be 900, it would be 2,800. I add them together. This is something annually. If I want to calculate the present worth, I will find the present over annual, 8%. The life of this, the second project is 12 years. That's the reason I mentioned 12 over here. According to the compound table, the value would be 7.5361 times out of these two number 3,700. The total value would be 27. The annual of the maintenance, the fixed value would be 160. The gradient value would be 100. So 160 present over annual, 8% and 12. Gradient value, which is 100. present over gradient, 8% and 11 because it will be increased from the second year. So we will calculate the total value. We will calculate the total value. It would be 4232. And for the salvage value, it's 7,500 is something for future. So we have to calculate present over future, 8%. The life of the system is 12 years. According to the compounded table, this value would be 0.3971 times 7,500. Total value would be 2978. Now is the time for adding all together plus this one. This one is the present worth, so we shouldn't change the using any factor. So we'll add them all together. Just keep in mind that the salvage value is minus because the rest of them is cost. The salvage is the income. We will add them all together. The total value would be 41137. Now is the time for comparing A and B, present worth of A and B. But as the present worth of A is less than present worth of B, we will choose A according to present worth criteria. Do both methods, present worth and annual worth, always yield the same decision in part D? No, especially when study periods are different, we cannot say that both of them have the same value and result. As machines have different lifespan, annual worth method is preferred. So when we have a question which have different lifespan, it's better to use annual worth method. And present worth depends on discount rate and lifespan. Thank you. Thank you for watching this video. Wish you the best and see you later.